So we proceed next to line graphs. Line graphs are very, very useful in showing a two-dimensional set of data where the x-axis and the y-axis are both represented in the graph. And for the most part, the x and y-axis would display ordered variables. What are ordered variables? Time is an example of an ordered variables. 10 a.m. comes in that order before 11 a.m. and 11 a.m. to before 12 p.m., 12 p.m. before 1 p.m., and so on. This is an order, there's an internal order to how the data values are sequenced one after the other. So this, for example, represents different times of the day and the number of people in the store. That is, counting the frequency. So on the x-axis, or the horizontal axis, we have keyed in the time, which is the ordered variable in this case. And the number of people that are in the store at 10 a.m., which is 2, spotted, 11, at 11 a.m., 5, at 12 p.m., 10, and so on and so forth. When we represent ordered variables in a line graph, the beauty is that we are immediately able to see at a glance that, for the most part, if this data represents what typically happens on a typical day, most people are in the store about 1 p.m. Let's consider another example. In a survey, several people were asked how many years it has been since they last purchased a mattress. The results were shown in this table, and we're to create a line graph for the data. Well, I can see years here. I'm going to let that go since it's a time ordered variable. I'm going to let that be on the x-axis. So I'm going to have 0, 1, 2, 3, 4, and 5. And then I'm going to also have the respective frequencies. This goes as far as 22. There's a 2 here. So I'm going to go in jumps of 5s. 5, 10, 15, 20, and 25. Then I am ready to work with, for 0, it corresponds to 2. So 1, 2, 3, 4. So I have 2 right here. And then for 1, it corresponds to 8. 6, 7, 8, 9. So this will be 8 right here. Then for 2, it corresponds to 13. 11, 12, 13, 14. So this is 13 right here. And then for 3, we have 22. This is 16, 17, 18, 19, and then 20 here. So that will correspond to 22, 21, 22, right here. And then for 4, we have 16. So that will be 16, 17, 18, 19. This is 16 right here. And then for 5, it is 9. So you have 6, 7, 8, 9. So right here. So I can draw my graph, my line graph, that way, this way, and then this way. And immediately, we can see that for most people, the number of years since they last purchased a mattress was 3 years. So, a very similar graph to line graphs is graphs used to represent time series graph. As we learned in the previous chapter, time series data is data that is collected sequentially in time. So, a time series graph is a line graph of repeated measurements taken over time intervals. Usually the time is shown on the x-axis, and data points are drawn at regular intervals, and the points are joined just to show the time dependence using straight lines. Time series graphs helps us to show trends and compare trends and patterns. So, a good example is right here. You have year, we have the years, 1750 to 2050, and then population density. This is meant to be illustrative. And from here, we can see those line graphs, the connections between the different data points, and that helps us to see the trend over time, that there has been a decrease and then an occasional fluctuation. Now, let's see an example of how to interpret an already prepared line graph. So, we're to use the following graph to answer the questions. I'm going to look at the title first. This is the record high and low temperatures for Grayling, Michigan, a city in Michigan, by month. So I have time again on the x-axis. The question is, which month had the lowest high temperature? So we have to look at where you have high temperature. So what represents high temperature? That is the orange color. And where was it at its lowest peak? That would be in the month of January. So that month had the lowest high temperature. That gets us going. Question B, which month had the greatest difference between the high temperature and the low temperature? This is high and this is low. So which month has the greatest difference or the greatest gap? I would argue that that would be the month of March. Then question C, approximately what is the difference between the highest high temperature and the lowest low temperature regardless of the month? So we will not consider the month. We would only go and get the highest high temperature. The highest high temperature occurs about the month of July. So July, this is the highest high temperature. And then regardless of month, let's go and find the lowest low temperature. That will take us to somewhere here, which is about -40. And we're interested in, here we had about 102. And so the difference will be 102 minus -40. And that will be 102 plus 40, which is 142 degrees. Again, this is 102 plus 40. With that question completed, we proceed to the next example. Here we're told that federal flood insurance underwritten by the federal government was initiated in 1968. These federal flood insurance coverage has, according to USA Today, more than tripled between 1990 and 2004. So that is a claim. We ask for the data. So the data is contained in a file titled what? Flood, that contains the amount of federal flood insurance coverage for each of the years from 1990 to 2004. Our goal is to produce a line plot for this data set just to see if the claim is well justified. Here in our Excel file, you see the flood and the year of the flood. And I've copied this data and I've taken it into StatCrunch. I have flood and year of flood. To begin to plot your line plot, go to graph. We need index or time plot. So click on that. The only variable you need to key in here, I'm going to drag this aside so that we can see the data and how we set up the parameters. You do not need to key in the year of the flood since it runs consecutively in time from 1990. All we need to grab are the data values, and that is under flood. That is the only thing you should choose. Then, the next thing you want to indicate is this is a time plot based on yearly or collected yearly. And you want to indicate the start year. The start year in our data set is 1990, so 1990. And there are increments of only 1 year, 1990 to 1991, 1991 to 1992, and so on. Then usually, I encourage my students to increase the line size to about 3 so that it's bold. And then click on Compute. And I am going to zoom in on the line plot. So here we have the line plot, and that satisfies the requirement of this question. Then the next thing is to look at the line plot and communicate what your insights are. What is the relationship between the year and the amount of federal flood insurance? One possible way to interpret this trend is to say that there appears to be an approximate positive or upward linear trend. Let's look back at what that means. So, going back, we see that this can be approximated by a straight line, kind of, a little bent here and there, which is expected of typical real-life data, and it is actually climbing up, which means it is positive. So, this is very important. Now that we've learned how to graph a single numerical variable, whether it has a time component to it or it does not, it is time to look at how to graph two numerical variables, and the tool to use is your scatter plot, also known as a scatter diagram. It is a two-dimensional graph, which means it has one dimension, the x-axis, and the other dimension, the y-axis, of plotted points, and which represents values of one quantitative variable, and the horizontal axis, which also represents values of the other quantitative variable. Our goal when we draw a scatter plot is to see if there is some independence between the two quantitative variables or a dependence. To illustrate, let's take the first example here, which tells us that the owner of Main Drive Taxi Service has selected a sample of customer trips and has recorded the data on three variables: distance in miles, trip duration in minutes, and tip amount to the driver. Now, to better understand this data, the manager is interested in knowing the relationship between the trip distance and the trip duration, and also between the trip distance and the percent tip. So the data collected are as follows. And to illustrate a scatter plot, there has been a scatter plot drawn of trip duration versus the distance in miles. So what components of this plot should a good student of statistics or an aspiring data analyst report? Four things: direction, form, strength, and outliers. For the direction, what you might observe is this. And in this case, this indicates a positive direction. Then for the form of the relationship, it could be curved, it could be straight line or linear, it could be something exotic. In this case, this appears to be a linear form of relationship. Then you also talk about the strength of the relationship. That is, how are the points, how close or clustered around the line are they? And I can say that most of these points are very close to this linear line that approximates the relationship between trip duration and distance. So I can say a reasonably strong relationship or association, and that is because the points are clustered together. Then, are there any presence of outliers? I do not see a point like this that is significantly away from the line that approximates the relationship. So I would say that there are none. These can be subjective, just a caveat to note. Then we proceed to the next page, which is the last page here. And again, this is a story about congestion cost per person per year and peak period freeway speed. In which case, we can immediately, if we follow what we set up earlier, direction, form, strength, and presence of outliers, as far as direction is concerned, I see something of the sort, which means direction-wise, this must be negative. And then next, you have for the form, this is also linear. And then again, to remind us, the strength of the relationship, the strength in this case, I see most of the points clustered around the point. So I'll say reasonably strong, 2. Reasonably strong association between peak period freeway speed and the congestion cost per person. And then for presence of outliers, I would venture to say there are none. So if I was to describe this scatter plot of congestion cost against freeway speed, what I might say in terms of the direction, form, strength of the association, and the presence of any outliers is here given. And in a nutshell, I will put that in the following sentence. So I would say that based on the scatter diagram, it appears that there is a reasonably strong, positive, and linear association between congestion cost and freeway speed with no outliers suspected. This is an example of how to communicate your findings from the scatter plot.